All right, and welcome everybody. Twitch, YouTube, and BitChute. We decided to do an all-in-one video today. It's space weather, Earth weather, even going to cover cosmic rays. Here's the colorized magnetogram from SDO. We've seen mostly stable sunspots here over the past 24 hours. This is yesterday and today data from colorized magnetogram, and this sunspot has grown a little bit. This one has featured some migrating umbrae, but besides that, things pretty stable. So here's the intensity gram, and lots of information to blast through to kick off your week. Happy Monday. Here's global seismicity over the past 90 days as we see a 7 magnitude earthquake drought continuing. One weird quake over the past 24 hours was this one here, occurring very close to the geographic North Pole. In the Arctic Ocean, it was a 4.5 at 84.978 degrees north latitude. I figured I would cover that one since it's not going to appear on the map here. Besides that, a quite calm 24 hours here, seismically speaking. No big earthquakes at all. Among the largest was a 5.2 at Indonesia. There was also a 4.6 in the Greenland Sea there, north of Norway. That 4.5 near the North Geographic Pole came in at 1802 Universal Time. Largest quake of the past 24 was a 5.6 in the Easter Island region. There you go. That one happened at 2320 Universal Time last night. Anyway, there's the rest of your list. Let's continue on to cover volcanoes before we get back to space. So Krakatau's continuing to erupt here in an explosive fashion. 9,000-foot ash plume from Krakatau. 16,000-foot ash plume over Guatemala from Fuego as Fuego explodes. Sangay exploding in Ecuador. 20,000-foot ash plume, flight level 200. 23,000-foot ash plume over South America in the Peruvian region. Sabancaya also exploding, flight level 230. Now getting into space once again, and this is usually where our YouTube exclusive video begins, showing some composite imagery here. Ionized helium plus ionized iron, 304 plus 94 angstroms. It's good times. That's the last 24 hours on your closest star, and let's subtract the 94 angstroms and show just the ionized helium. Once again, these sunspots have been mostly stable. We've seen a reduction in the radio flux and the X-ray output. Only some C-class intensifications here over the past 24 hours. Radio flux now down to 166 solar flux units. So now back down to this point on the graph. That's the one-year chart. You can look at it yourself on solon.info if you like. Space Weather Enthusiast dashboard here. NOAA not forecasting any geomagnetic unrest or geomagnetic storm conditions. We're forecasting some geomagnetic unrest or storm conditions midday tomorrow, and some additional ones midday on the 20th. So tomorrow, July 19th, Tuesday, and Wednesday, July 20th. Expecting coronal mass ejection strikes on both days. NASA agrees with our strike tomorrow. NOAA, not so much. So we are expecting it to be a glancing blow, not a direct hit. Let's take a look at the Earth's geospace. So here's Earth's magnetic moment from space over the past 4 hours. And we see a very geomagnetically calm environment. Remember, folks, we think that the plasma is swept away by ongoing coronal high-speed streams and coronal mass ejections. So we're expecting to see a very significant signal tomorrow around midday. That was Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. Our geospace magnetosphere movie, ground magnetic perturbations. Again, geomagnetically calm conditions here over the past 4 hours. And let us know in the comments what kind of coffee you're drinking today. Today we're drinking organic Mexican Chiapas. Organic Mexican Chiapas whole bean is what we're drinking today at the Smash News Network, least busted name in news. And hey, once again, thanks everybody for tuning in. Planetary K index only at 2 at the moment. For you new viewers, Planetary K index, a measurement of global geomagnetism. And let's take a look at the real-time solar wind. We've got a very low solar wind density here. Looks like a fairly believable number there. Only 2.6 protons per cubic centimeter. Make it 1.9 protons per cubic centimeter. And now dropping below 400 kilometers per second for the solar wind speed. 393 kilometers per second is the apparent solar wind speed. There are your GOES magnetometers. And we're expecting to see continued rather low readings here in the GOES magnetometers. Let's take a look at some magnetic data from the Global Oscillation Network. It's our GONG-2 data. If you're wondering where it comes from, it's derived from 51 ground-based magnetometers, as well as magnetometers on stereo A and stereo B. So there's your top view ecliptic plane field plot. Earth solidly in a south pole current sheet. No sudden changes expected in that. Keep in mind the magnetic environment can suddenly change with basically no warning. Here is our line of sight plot, and you can see the solar polar field progression happening there. South solar polar field making its way into the earthly facing zone. And moving into coronal holes, there you can see some well-defined coronal holes of south pole orientation showing up trans-equatorially, crossing the solar equator. So here's a great close-up of those in 193 angstroms from SDO. And it's a great wavelength for a lively-looking star. And let's zoom out and show the full solar disk. We still do have a pretty high likelihood of solar flares. And we'll get into sunspots next. What evil lurks in coronal holes? Well, high-speed proton streams typically lurk in coronal holes. So here's your detected sunspot groups and flare probability. Again, flare probability is still quite high here, as these are all beta-gamma class sunspot groups. Alpha class sunspots have only one magnetic field associated with them. Beta class sunspot groups have both north and south pole magnetic fields and are much more likely to produce major flares. That's the current environment. And here's the 1700 angstroms wavelength. I would say the most likely place to see major solar flares would be from this setting sunspot group right over here, as large flares are more likely to happen around the limb. It's just a fact. It's an interesting fact. And let's blast through lots more data. We've got plenty more to cover. So there's your X-ray profile over the past 3 days. Again, only C-class intensifications have been seen. No relativistic particles. And let's talk about cosmic rays. Interestingly, over the past 30 days, we've seen an uptick of cosmic ray flux. So there, that middle pane, that's the Apatity neutron monitor over the past 30 days. Again, an uptick there at Apatity. And coming down to the bottom, we see an uptick at Barentsburg as well. So there's an uptick in cosmic ray flux. Let's go much farther south to Athens, Greece, also showing an uptick over the past 30 days. Let's go even farther south to Mexico City, also showing a minor uptick in cosmic ray flux over the past 30 days. So it's pretty much worldwide consensus here. All the cosmic ray monitors agreeing. Now going way back north to Oulu, Finland, also showing an uptick over the past 30 days. Keep in mind, here's DOMB Antarctica, going all the way south, an uptick at DOMB, and a similar uptick at DOMC. So an uptick in cosmic ray flux over the past 30 days there, pretty much across the board. We like to report on that at least once a week, as, well, our Gold Smash Team members would probably agree that cosmic ray flux is kind of important. So next, going to the solar flare view. This is 94 angstroms. And we've only seen C-class intensifications here. That is the last 24 hours from SDO, the Solar Dynamics Observatory. And continuing on here, we've got plenty more to cover. We encourage our viewers to look up, and this is what the sky would look like above head in Lehigh Valley if we could see it. It's very cloudy in Lehigh Valley at the moment, but that's what's going on. We've got Saturn, the Moon, Jupiter, Mars, and Venus all rising ahead of the Sun. Here's your solar system forecast. We've got a gibbous waning moon. Let's show the 1 week forecast. There's where things will be in a week. Keep in mind, this imagery is not to scale. We will have a crescent waning moon in 1 week. Today's featured product is Do Not Pole Vault the Caldera. It's a message of positivity. Because if you're going through hell, keep going. I truly believe that our finest days lie ahead. So don't come up with a permanent solution to a temporary problem. And don't pole vault the caldera. We need the views on YouTube. So check out some merch. You can find the links below the video as well as on our homepage at smashomash.com. Spectacular high-res imagery there. Perhaps to create some laughs and to discourage your track and field team from visiting volcanoes to attempt to pole vault the caldera. Press like and subscribe if you enjoy the content. Help us out that way. The algorithms, well, they seem to be less than helpful. Algorithms, such as the ones on Facebook, have caused us to create our own website, smashomash.com, and welcome to the Neo-Renaissance. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the Internet Underground, where we survive as producers of fortune. If you've got a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. So check out the Smash Team site. If you aren't seeing all of our videos in your subscription feed, head to smashomash.com/smashteam and click posts. And if you want to support the channel via subscription services, consider becoming a silver or gold member of the Smash Team. Thanks to those who have. We just launched it in October of 2021. Shout out to all of our Smash Team members. There's also a bronze membership. And if you want to leave comments, you do have to log in. This video was originally streamed live to Twitch at twitch.tv/smashomash. The main live streaming feature at the Smash News Network, least busted name in news. Let's get back to it. Looking at your coronagraphs here for yesterday. We do see some additional coronal mass ejections. Again, we are expecting a coronal mass ejection strike around midday tomorrow on July 19th, Tuesday, and some additional coronal mass ejection strikes on Wednesday around midday. That was yesterday. Here's today. Today so far, July 18th. We'll also show some additional coronagraph imagery from Lagrange Point 1. the location of the Soho Lasco C3, and at Lagrange point 5, the location of stereo A's coronagraph shown here on the left, Soho Lasco C3 here on the right. We do have one interesting CME showing up here right at the beginning of our video. And it looks like no additional ejecta headed our way besides what we've already covered. And we tend to be pretty prompt with our coverage. So that's what happens when you immerse yourself in the data, folks. The daily space weather videos, just the most detailed imagery of the sun and of space weather, and the most detailed information on the entire internet. Once again, congratulations on realizing that content exists. Here's your hydrogen alpha imagery, and we still do have quite a few filaments. Some new filaments rising over here in the east, and likelihood of coronal mass ejections remains quite high. Likelihood of solar flares remains quite high. Here's the latest imagery from the NASA GOES 16 SUVI. The delightful wide field of view. A little lower resolution than the Solar Dynamics Observatory. That's about the last 2.5 hours of ionized helium. And this is where our YouTube video usually ends. Today it will continue on through our bonus features and our meteorology content. So that's the house favorite, 171 angstroms for the past 24 hours. And let's get into the bonus features. Total electron content showing some anomalous electron contents once again. We are seeing some charging hazards, which we'll get to in a moment. So GPS errors here extending well outside of the normal range. Most GPS errors happen around the equator at noon. And we're seeing some electrons a bit out of place here at the moment. And your GPS satellite's located at about 12,500 miles of altitude. And if it has to communicate through a lot of free electrons, it has a tendency to have a refracted signal. Here's our satellite's community dashboard, and we're seeing some significant internal charging hazards. This is caused by high energy electrons making it into the internal circuitry of satellites. There you can see some internal charging hazards over the southern Pacific, southern Indian Ocean there, places like Oceania, Papua New Guinea, Indonesia, and northern Australia. So that could create some communications breakdowns for satellites. And we are seeing a little dip in the electron flux here. Keep in mind that's midnight local time for the satellites. So that's midnight time for the GOES 16. There's midnight for the GOES 17. That gives you some indication their location in their geosynchronous orbits. As we said yesterday, we expected a little higher levels than NOAA forecasted, and indeed we do have higher levels of electron flux. And there's the 1-year chart to put it in context. That's the NOAA forecast. That's the 1-year chart from Solon.info. We'll also show the ionosphere, the bridge between Earth and space. And the F-flare is located at about 300 kilometers of altitude. Here is the vibrational frequency of the previous day. So lots of shaking going on in the diffuse portion of the atmosphere known as the F-ionosphere layer. A lot of charged particles up there, as there is a lot more ionizing radiation up in the ionosphere than there is down here on the surface. We'll show the anomalygram as well. Here's the anomalygram showing anomaly in megahertz from the 30-day median. And we're seeing a more diverse series of anomalies here in the ionosphere at the moment, as we were in a mode where we were seeing only low-frequency anomalies for weeks at a time. There's the latest image, 10 o'clock Universal Time ionogram, 10 o'clock Universal Time anomalygram. Here's your latest intensitygram and latest colorized magnetogram. We've still got about 7 named sunspot groups at the moment. And let's do a composite. This is 3 different wavelengths from the SDO. 211, 304, and 171 angstroms. That's yesterday and today, July 17th and July 18th. Zoom out to show the full disk and as much of the corona as will show up. And let's do meteorology. So here are the jet streams of the eastern world. Shout out to our viewers from all around the planet. Let me just check the life of the stream here. Everything looks just fine. Jet stream blowing backwards over the western Pacific and central Indian Ocean. Here are the surface winds of this side of the planet. Surface winds of the Americas as this low pressure continues to linger off the coast of Mexico. It looks like it's actually intensified a little bit since yesterday. Jet streams of the Americas look like this. As we continue to see this anticyclone over the central U.S., you can see this strong clockwise rotation there, indicating an upper level high pressure. Here are the jets of Europe, Africa, and the Middle East. Anticyclone over southern Africa as well, rotating counterclockwise as they do in the southern hemisphere. And there are the surface winds. Let's move on to our weather.gov map. We've got continued gale warnings around Hawaii and Alaska, and some excessive heat across the entire central portion of the U.S. If your county's lit, click your county. It's a foggy morning on Lake Superior. Here's your NASA GOES lightning mapper, and some strong lightning there moving across Missouri, Arkansas, western Kentucky, and Tennessee. As the lightning month of July continues. And here's a real-time lightning map. We did stream this video live originally, so let's take a quick look at terrestrial strikes. Looks like we've got some lightning here over eastern California, southeastern California there. Around Kingman, Arizona. If you're in Las Vegas, go look south. You may see something going on above those cloud tops like sprites, green elves, blue diamonds, purple horseshoes, and pink hearts. It looks like we've got some lightning not too far from home here. And some lightning there around the Delaware River, around the Pennsylvania-New Jersey border. Zooming out, there's your global lightning view from lightningmaps.org. Check it out next time you hear thunder. Here's your GFS lower 48 pressure and precipitation forecast for the next 72 hours. And we like to follow Reed Timmer on Twitter. We regularly share some of his storm-chasing posts. Follow us on Twitter as well, twitter.com/smashamash. You'll see all kinds of shares you won't see anyplace else. Despite the pathetic censorship on the platform, we're still there. And I just wanted to zoom in on the lower 48 here. Here's the GFS 72-hour pressure and precipitation forecast for the northeastern region. I thought there was going to be a little more severe weather than this, so let's just continue on. Since everybody's talking about how hot it is, here is your temperature forecast based on the European model. And we're just going to let this advance to see when the hot European temperatures are going to break. And it looks like they're going to be breaking pretty soon here. Certainly some hot weather coming back for tomorrow. Over large portions of the Western world. Let's see if Wednesday's going to be as hot. Wednesday looking pretty warm as well. And we'll pause this about midday Thursday. There's where things are expected to be at 12 noon Eastern Time on Thursday. Let's continue on to our current data here. This is your U.S. Doppler radar map. There's all 50 states. And you can see a line of strong storms here stretching from Mississippi all the way up to Cleveland and beyond. Just making it to Albany, actually. Here's your shortwave radiation map showing clouds and fog. It's too dark to use the visible satellite, so we use the 3.9 nanometer infrared radiation satellite. And last but not least, there is the water vapor. You can see that clockwise rotation happening there, right in the center of the country. And how about a recap? Ground-based radar systems detecting vertical motion of water droplets. Those are the Doppler radars. There's clouds and fog from the NASA GOES Interactive Weather Satellite Suite. And there is the water vapor. Once again, happy Monday. Thanks for tuning in to our composite coverage here, including the space weather and the Earth weather. We'll see you soon at the Smash News Network, least busted name in news, and may that solar wind be at your back.